Two variable systems of equations. A system of equations is a set of two or more equations that share the same variables. In this concept, we're just going to look at systems that have two equations. Later on, we'll look at systems that have three. The three ways that we are going to solve these are by graphing, substitution, and elimination.
When you solve a system of equations, there are three different situations that you can have. You can have one solution, no solutions, or many solutions. So sometimes when you are graphing your two lines, they are going to cross in one spot. So we'll have one solution. So that's an example of what a graph of two lines that have one solution will look like. So in the next section of Concept 3, you're going to talk about how to solve systems algebraically using substitution or elimination. And so in that case, when you solve the system, you will end up with an ordered pair, an x and a y, that indicates where those two lines are crossing, and that's their solution. And in this case, it's the point 0, -1. The second situation is you can have a system that has no solution. And so these will be two lines that are parallel, so they'll have the same slope but different y-intercepts. And when you graph them, you can see by the graph that they will not cross. So again, we would call this system a system of no solution. When you're solving algebraically and cannot see the graph, both your x and y will eliminate, and you'll be left with a false math statement. Something like 0 equals 5, or another number, but you'll have two numbers that clearly do not equal each other. So that's a false statement. So that's an indication that you have a system with no solution. And then finally, you can have a system with infinitely many solutions. When you're graphing, these will look like two lines that graph right on top of each other. They are crossing in many points. Actually, they are crossing in infinitely many points. So we say that this system has infinitely many solutions. When you're solving algebraically, as you'll learn in Concept 3b notes, you will get a true math statement. So your x and your y's will eliminate, and you'll get something like 0 equals 0, or another number like 5 equals itself. Let's solve the system of equations that we see in number 1. 4x minus 3y equals 9, and y equals 1. So the first thing we want to do is to rewrite that first equation in slope-intercept form. So I'm going to recopy my equation, and then I'm going to start by subtracting my 4x over, because I want it to be in slope-intercept form. Then I want to divide everything by -3, so I need to divide both things on the right side of the equation by this. So now my equation will be in slope-intercept form, so y equals positive 4/3 x minus 3. So now I have my y-intercept and my slope, and I can use those to graph. I'm just going to recopy my second equation, which is a horizontal line through the point where y equals 1. So now let's graph. Let's graph the equation in blue over on the left. So my first point is going to go where y is -3. And then my second point will go up 4 and over 3 using my slope. I draw my line, and you can see that I have my blue arrowheads at the end. My second line will be a horizontal line through where y equals 1. And now I'm looking where these lines are intersecting. This is the solution. This is the point that is shared between both of these lines. So I look at my x and my y axes. I see on my x-axis I'm going to move over 3. And then on my y-axis I will move up 1. So the solution to this system is the point 3, 1.
Number 2, solve the following system by graphing. I want you to go ahead and pause your video and solve both of these equations for y, get them into y equals mx plus b form, and then check back with me. Okay, on the left side, I started by moving over the 1 and then the x. You may have done this in different steps than I did, but as long as we got to the same equation at the end, we're good. On the right side, we had a little bit of a tricky part right here whenever we divided everything by a 3. A negative x is just the same thing as a negative 1x, so that ended up being negative 1/3. Okay, go ahead and pause your video and graph these two and make sure you write your final answer as a point. Our final answer ends up being the point 3, 2. Solving systems using substitution. Here are the 4 steps that we're going to use. Number 1, solve for one variable if there is not already one solved for. Step 2 is take what that variable is equal to and plug it into the other equation. Step 3, solve for the remaining variable. And step 4, find the second variable and write your final answer as an ordered pair. Okay, the first thing is we need to have a variable solved for, which in this problem we already have. See how it's x equals the rest of the equation? So we have our x solved for. So what we're going to do is we're going to take what x equals, the 3y minus 3, and we're going to plug it into the other equation for x. So here we have rewritten the top equation, but instead of putting an x, we plugged in 3y minus 3. Go ahead and solve this equation by distributing your 3 and solving all the way for y. After you solve for y, you should get 1. Now take that 1 and plug it back into one of our equations where you see a y. I think it looks easiest to plug it into the bottom equation since we already have x solved for in that equation. So when I plugged 1 in, I solved and I got x equals 0. So my final answer here is the point 0, 1. Problem 2 says solve the following system by substitution. So recall back, the first step is to solve for a variable, which we don't already have done here. We don't have anywhere that has just x equals or y equals. So we can pick one of any of these 4. To me, the easiest one looks like it's this y, because it doesn't have a coefficient in front of it, and it's positive already. This x has a negative in front of it, so we'd have to deal with the negative. So let's solve for this bottom y right here. The way I'm going to do that is I'm just going to move my x over, and my new equation is y equals x minus 1. Okay, we're going to take this x minus 1 and we're going to plug it into the other equation for y. We're plugging it in for y because it says y equals x minus 1. Okay, so we're going to start with distributing the negative 3. Make sure you bring the negative with it. Combining like terms, moving things over, and we get x equals 4. Now that we have what x equals, we're going to take it back to one of our equations from the beginning, and we're going to plug 4 in for x. So in the end, we get the answer of 4, 3. Remember, if I went too fast on this, make sure you pause your video and copy everything down. Our next method for solving is elimination. This is personally my favorite way to solve systems. Step 1 here is we're going to create opposites. So we want to create some things that add up to 0. My example here is negative 2y and positive 2y. Step 2 is we're going to add the two equations together. So we're going to add down, and it's going to eliminate whichever variable you made opposites in because they will add up to 0. And we'll be able to solve for whichever variable is left. Step 3, go back and find the other half of your ordered pair. Okay, so in problem 3, we're going to solve by elimination. Our first step is to create opposites. You always want to see if opposites are already there for you. So my x's aren't opposites because 1x plus 2x adds up to 3x. But my y's are opposites. I have negative y and positive y. They add to 1. So we are ready to go with this problem and just add down. When I add my x and my 2x, I get 3x. And when I add the 11 and the 19, I get 30. Make sure you bring your equals down and notice that our y variables canceled out. Okay, if I finish solving this for x, I'm going to get x equals 10. My next step is to take whatever x equaled and plug it back into one of my two original equations. You can use either of the equations. I think that the top one looks like it's the easiest. So I'm going to put 10 where x was and solve for y. So let's subtract the 10 over. Since I have a negative y equals number, I'm just going to change all my signs, and I get y equals negative 1. So my final answer is the point 10, comma, negative 1. You can always check yourself on any of these systems problems by plugging the numbers back in for x and y. So if I go back to my original two equations and I plug in 10 for x and negative 1 for y, I should get a true statement for both of those equations.
Now let's look at number 4. Let's solve this system using elimination. So our first thing is we want to create opposites in one of the variables. So I look at the x's and I notice if I multiply my bottom equation by 2, then I will have opposites with my x's. I will have negative 2x and positive 2x. So that's what I've decided to do. I'm going to put a parentheses around the whole equation and put a 2 out front. So I'm going to rewrite my first equation, negative 2x plus 6y equals 6, and then I'm going to distribute my 2 to the second equation. 2x minus 6y equals 6. Now I can add these equations together, the x's, the y's, and the numbers, to eliminate a variable. So negative 2x plus 2x will eliminate to 0. 6y and negative 6y also eliminates. Sometimes that happens. So I just write what I have. I have 0 plus 0 equals 12. I'm going to simplify that to just 0 equals 12. That is a false statement. When we have a false statement and we're solving algebraically, either using substitution or elimination, that is an indication that we have no solution.